Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and it's our second video on brackets involving surds. Now to start with, a brand new idea. Something called conjugates I want to introduce to you that's going to be useful throughout our maths career. Now suppose I asked you 10 add 3 multiplied by 10 subtract 3 both in brackets. You know how to work that out with the distributive law. You know that what we can do is as follows. 10 multiplied by both the terms in the second bracket and 3 or positive 3 multiplied by both terms in the second bracket. So let's write this out in full. We're going to get 10 multiplied by 10, okay, and 10 multiplied by negative 3 is take away 10 multiplied by 3, and here we're going to get 3 multiplied by 10, so add, we can say 10 multiplied by 3, and then positive 3 multiplied by negative 3 is take away 3 multiplied by 3. Now, I'm trying to show you something's going to always happen here. You see the negative 10 multiplied by 3, and you see here we've got the positive 10 multiplied by 3. They clearly are going to cancel each other out. This is going to be negative 30 if we work it out. This is going to be positive 30 if we work it out. And their effect on the overall answer isn't going to change. Now 10 times 10 has to stay there. That's 10 squared. Let's write that as 10 squared. And 3 times 3 has to stay. That's going to be 3 squared. But it's negative 3 squared. And the answer therefore, 10 squared is 100, 3 squared is 9, 100 take away 9 is equal to 91. Now, always when you have a case of 10 add 3 multiplying by 10 take away 3, you're always just going to get 10 squared take away the 3 squared. There's a name for this here. 10 add 3, its conjugate is 10 take away 3. The conjugate of a number, let's say 10 add 7, the conjugate of 10 add 7 is 10 take away 7. And when we multiply 10 add 7 by its conjugate, we're always just going to get 10 times 10, 10 squared, take away 7 times 7, 7 squared. Now I'm going to prove it to you in one more case where I write it out fully, but in the last case we're just going to do it using the rule. And actually there's a word for this which you'll see in algebra, and it's called the difference of two squares. So this is our first time we've ever seen it, but we're going to see it in algebra later. So let's do this long ways as well. 20 multiplied by 20 we'll write like that. 20 multiplied by negative 9 we'll subtract 9 times 20. Here we're going to write positive 9 multiplied by 20 is plus 9 times 20, and positive 9 multiplied by negative 9 is subtract 9 times 9. Now can you see what I was saying works again here? You've got negative 9 times 20 and you've got positive 9 times 20. They are going to cancel out, and what you're left with is 20 squared subtract 9 squared. Now 20 squared, 20 times 20 is 400. Take away 9 squared is equal to 81. You're going to get yourself the answer 319. Simple as that. So because we multiplied 20 add 19 by its conjugate, 20 subtract 19, we always get 20 squared take away 9 squared. Now the last one, I'm not going to show you the middle cancelling. I'm just going to assume that you can spot that we've got a number here, 50 subtract 1, multiplied by its conjugate, 50 add 1. This is the conjugate of this. Obviously, if the conjugate of this one is 50 take away 1, they're both conjugates of each other. So I look at that and I say, right, I know the middle term's going to cancel. That's 50 squared. It's always a take away 1 squared. Now 50 squared is 2,500. Take away 1 is going to be 2,499. Now who would have thought you could do that in one move? And we're going to use that a lot in this video coming up. Also, we've previously simplified the following things on Hegarty Maths. Root 3 all squared, well that's root 3 times root 3, and which is going to be 3. Root 2 times root 2 we know is going to be 2. What about this? Root 2 times 3 root 2. Well, we know we can do the multiplication in any order, so we know we can do root 2 times root 2, which is 2, and we've still got a times 3, so this is 3 times 2, which is 6. Now the last one, can you spot the similarity to what I was talking about before? 2 root 3 is getting multiplied by its conjugate to subtract 3, okay? And we can apply what we did previously. Without having to work it out, I'll multiply it all out. When you see 2 add root 3, multiplied by its conjugate, you can say the answer for sure is 2 squared subtract root 3 all squared. Now 2 squared is 4, root 3 all squared, well we know that it's 3, this is 4 take away 3, this is 1. Let me prove to you on the calculator that definitely works. Bracket 2 plus root 3, open bracket, 2 subtract root 3 and close bracket. If I get 1, what I told you is definitely right. And there you go, it is. So this technique here we're going to use throughout the video. Let's give it a go at simplifying some surds. Simplify the following. Root 3 multiplied by root 3. That's root 3 all squared, which we know is 3. Root 5 all squared, we must know that one, it's just 5. Root 5 multiplied by 4 root 5, I can do the multiplication in any order. Root 5 times root 5 must be 5. You've still got a times 4. This is 4 times 5. This must be the answer, 20. And this one here, we can do the root 3 times the root 3, and that's going to be 3. So this is we've still got the 4, so this is going to be 4 times 3, which is 12. Right, nice and simple there. Now, here, root 2 plus 1 multiplied by root 2 subtract 1. Alarm bell should be ringing. Here, we've got root 2 plus 1. We're multiplying it by its conjugate, root 2 subtract 1. So we know when we do that, we can just do the first term squared, root 2 all squared, subtract the second term squared, 1 squared. Root 2 squared is equal to 2. 1 squared is 1, so this is 2 take away 1, which is 1. What about the next one? Exactly the same thing going on. We've got root 3 take away 1. We're multiplying it by its conjugate, root 3 add 1. So what are we going to get? Well, we know that's going to be root 3 squared take away the answer of 1 squared. Root 3 squared is 3. 1 squared is 1. 3 subtract 1 is 2. So nice and straightforward. Last one, 2 plus root 3 multiplied by its conjugate, 2 subtract root 3. Same thing applies, so what are we going to get? We're going to say the answer is 2 squared, take away the answer to root 3 all squared. Now 2 squared is 4, root 3 all squared is 3, so this is 4 subtract 3, and the answer is 1. Okay? Let's try some more. Exactly the same thing is happening here, so we can just spot straight away that this is going to be the first term squared, root 7 squared, take away the second term squared, which is 3 squared. Root 7 squared is 7, 3 squared is 9, so 7 take away 9 is negative 2 by the symmetry of subtraction. Okay, next one. 3 plus 2 root 2 multiplied by its conjugate, 3 subtract 2 root 2. So we know it's going to equal, well, the first term squared, which is 3 squared, take away 2 root 2 squared, so 2 root 2 squared. Now 3 squared is 9. 2 root 2 squared, well, I'm just going to write that as 2 root 2 multiplied by 2 root 2. It's easier to see what's going on. So we've got 9. Now 2 multiplied by this 2 is 4, and root 2 multiplied by this root 2 is 2. 4 times 2 is 8. So it's 9, subtract 8, and the answer is 1. And last one on this page, we have root 5 subtract root 3 multiplied by its conjugate, root 5 add root 3. So we know the answer is going to be root 5 all squared, subtract root 3 all squared. Root 5 squared is 5, take away root 3 squared is 3, 5 subtract 3 is 2, and we're done. So next question. What surd could I multiply each of the following surds by to get a whole number? Now maybe you've spotted what's been happening in this video. All my answers have been whole numbers to all the multiplications I've done. So here, when I multiply a bracket by its conjugate, I've been getting a whole number, here and here. And similarly, when I multiply a square root by itself, I get a whole number. So, going back to the question, what would I need to multiply root 3 by to get a whole number? Well, the easiest possible one to multiply it by would be root 3, because I know for sure that would get me 3. What about 2 root 2? Well, I could multiply it by 2 root 2 again, or I could just multiply it by a single root 2, because root 2 times root 2 is 2, and 2 times 2 is 4. That's the easiest one for me. What about this? Well, the easiest one would be root 3, because root 3 times root 3 is 3, 5 times 3 is 15. Now what about these? What would I multiply these by to get whole numbers? What have I been talking about in this video? Well, I could multiply it by its conjugate, 3 plus 2 root 2. And here I can multiply it by its conjugate, root 5 subtract root 3. And here I can multiply it by its conjugate, 2 plus root 3. And I will always get a whole number answer. In fact, I've done these questions in this video already, and I actually got the following answers: 1, 2, and 1. And this is something we're going to do in the last two videos on surds, how to get rid of a surd, or what to multiply a surd by to make it a whole number. So I want you to look at this, make sure you can spot the pattern so you're ready for the next video, and it's called rationalizing surds. Thanks for watching.